All right, so welcome to the third Lego class, 2026. And so one of the big things we need to do is we need to try to figure out what is a realistic time for you guys to build the sets. One of the best skills you can get in life is the ability to make quick ballpark estimates. It does not have to be perfect, but it should be somewhat close. I was talking to my son about this, even though he is not able to participate in person. He is happy to help me with stuff like this. He does not like the fact that I can do these calculations pretty quickly. He finds it very frustrating. It's a good skill to have. And so I asked you to do the builds in groups of 1, 2, 3, and 4 per letter. And the numbers that I have from you guys just don't pass the smell test. Now, it could be, and again, I'm not saying that maybe hockey players are not as talented as football players at building Legos. Data may suggest that, but I'm not saying that. It may be that some of you are just damn good at building. Others of you might just be phenomenally bad. It could be a little bit of both. It may be that you don't know how to play well together. This is not a skill that is necessarily looked at in admissions when they're trying to determine who should be admitted. But at one point, I think when we went from 2 to 3 people, the time dropped. I'm sorry, the time increased. It took more time to build with 3 people. I don't think it should be taking 3 people longer than 2 people. Now, it is possible. Since this is being recorded, I will be very careful. When I was in high school, I was in a class where we had a test that was done so poorly by the class that the teacher decided to curb the exam. She would let us retake the test in groups. The average score fell when we took it in groups. And part of it was certain people were able to convince others that, oh, no, this is the right answer for this problem. It is possible sometimes that more does not mean better. But for something like building, this is just not passing the smell test that you guys got worse in some places with more people. It could just be that somebody is really bad and you have to find a polite way of giving them a job that makes them feel like they're doing something while they're not actually harming things. This is the old T-ball. This looks like a really power hit. I want you to play deep second base right now so that they don't collide with each other. So what I want to do today is I want to do another rebuild. I want to do it again. I will try to watch you guys and see what's going on and make sure we have the data accurately done. You still, and some of you have not fixed the data for how the times were inputted. It's really important to enter it in a nice way. It makes it easier to apply certain mathematical operations to get a sense. So I thought I would give you a problem to think about right now. We'll talk about it in class, and then I'll give you a quick estimate of how I would attack this as a way to try to get an estimate of whether or not something is reasonable. A lot of times, how many of you have taken physics class or chemistry class and seen really big numbers that are just really hard to parse? One of my favorite examples was a physics book was talking about this energetic radiation, and they gave the value. Most of us have no understanding of what these numbers mean for how strong radiation is. What the book said is, imagine you go to the dentist's office. I can't remember if I've done this already. And you know how they put that lead apron on you to protect you from the radiation? They said if the lead apron had a thickness running from the sun to Pluto, it would not be enough to stop this radiation. That gives you a sense of just how powerful this radiation is. It takes a number and it gives some kind of units. So I was reading Malcolm Gladwell's The Tipping Point this morning while out for my jog, and he had the following statement. If you fold a standard piece of paper 50 times, will it reach the sun? Now, some of you may be stronger than others. I had a rough thought as to how many times I could fold a piece of paper. I was off by 1. If I really pushed, maybe I could have gone that 1. Anybody have any idea roughly how many times you think you can fold a piece of paper? 7. I went with 7. I was off by 1. I could do. This is your chance to kiss up. Yeah, that's the right way to kiss up. I could do 6. Every time you fold, what happens to the thickness? It doubles. Do you think if you folded a standard piece of paper 50 times that you could reach the sun? How many say yes? How many say no? How many don't know at all? How would you try to estimate this? Yes. So you need to know what 2 to the 50th is. So fortunately, I actually know what 2 to the 50th is, approximately. How many of you, anybody here, computer science major? All right, so it's just us right now. How many gigabytes are in a megabyte? Anybody want to help? No, 10 to the third. It would be 10 to the third if the computer scientists actually understood classical languages. How many is it? It's not 10 to the third. What base do humans use to count? 10. Why do we use 10? If you know the answer, raise your hands. Exactly, right? We have 10 fingers, right? We use base 10 to do operations. What do computers use? 2. So 2 to the 50th is 2 to the 10th to the 5th. 2 to the 10th is 1024. 1024 is approximately 1,000, which is 10 cubed to the 5th, is 10 to the 15th. So with a quick estimate, and I'm not going to be off by a tremendous amount. I know enough calculus that I could even quantify how much I'm off by. It's going to be a little bit higher than 10 to the 15 sheets of paper. That's a pretty good ballpark estimate. Let's try to calculate how far is it from the Earth to the sun in sheets of paper. That's going to be our new unit. Do people like sheets of paper as a unit of measurement? It's not bad. What's it a better unit than? Smoots, right? It's a much better unit than smoots. Anybody know how we would estimate how thick a sheet of paper is? We need that estimate if we're going to do this. That's one of the two numbers we need, yes. Okay, do you have a stack of sheets of paper on you? I'm sorry? We could search it up, but does anybody know offhand, maybe within a factor of 2, a fixed number of sheets of paper have approximately what thickness? This might be something professors know more than students. How is paper sold? Reams. Reams of how many? I think it's 500, but we'll check in a moment. Because not surprisingly, I do have a ream of paper in my backpack. Does anybody know roughly, just thinking in your mind, in inches, how much a ream would be within a factor of 2? Do you think it's half an inch? Do you think it's an inch, 2 inches, 4 inches, 8 inches, 20 inches? Yeah, good. Go something like this. Give me something within a factor of 2. So if I mean within a factor of 2, if you say 6, if the answer is anywhere between 3 and 12, you are within a factor of 2. If you say 5, within a factor of 2 would be from 2.5 to 10. So how thick do you think a ream of paper would be? In inches.
2 inches.
2 inches. It actually is about 2 inches. And so, here, ream of paper, 500 sheets. So what I can do is, in my mind, I can figure it's probably about 2 inches. If I wanted to measure this, if I know a piece of paper is 8.5 by 11, I know the bottom is 8.5. So if I fold it once, that's about 4 inches. If I fold it twice, that's about 2 inches. So I can actually measure a little bit more than 2 inches without too much trouble. Again, trying to give you some skills, so this is considered an accredited class for the purposes of Williams, winter study. This is a good skill to be able to quickly estimate. So we would say 500 sheets is 2 inches. Well, if 500 sheets is 2 inches, there's another number that's much better to work with than 500. 1,000. So 1,000 sheets is 4 inches. Right? So what we can do is we want to get how many sheets would it be to get to the sun? Anybody know roughly how far the Earth is to the sun?
Like 280,000 miles?
Nope. The moon is around 250,000 miles. Anybody know how long it takes light to get from the sun to the earth? No, about 8 minutes. That might be why you're off by so much. That might be why you're off by so much. So it's actually possible that the sun went nova. I don't know if the sun went nova. That minor issue happened on the sun. There's a flare coming, and we're all going to die in the next 7.5 minutes. We just don't know it yet. It's possible. We'll find out in a little bit. And maybe those shades will automatically go down. So it's about 8-9 minutes to the sun. If you know that light travels 186,000 miles a second, you can then use that to calculate. Or you might remember that the sun is about 90 million miles from the earth. Instead of using 90 million, what can I use? 100 million. So we could do 100 million, which is 1 million is 10 to the 6, 10 million is 10 to the 7, 100 million is 10 to the 8 miles. So we're rounding up a little bit. How many feet are there in a mile? 5,280. And so rather than doing that, I rounded up a little bit last time, so I'm going to round down a little bit. So I'm going to say this 5,000 feet per mile. Or to make things a little bit nicer, I might say it's 10 to the 4th. No. Yeah, 10 to the 4th would be 10,000 feet. Would be basically 2 miles. I'm just trying to keep the numbers as simple as possible so I can do this in my head. Does that seem reasonable? Let's do. How many? So does anybody remember this factor labeling from maybe chemistry class? Does this look vaguely familiar? You're keeping track of what the units are. How many inches are there in a foot? 12. And so I might even keep this as nice, and I might do then maybe there's 1.2 times 10 inches per foot. I know I've got feet and foot, but we'll deal with the bad English. And now we know we want to convert from inches to sheets. And we said 1,000, that's 10 cubed, is 4 inches. So if I multiply all this together, 10 to the 4th, 10 to the 8th is 10 to the 12th, 10 to the 13th, 14th, 15th, 10 to the 16. And I have 1.2 divided by 4. So that's about 0.3 times 10 to the 16. Oh, I have an extra 2 down below. I forgot about the 2 there. So it's 1.2 over 8 times 10 to the 16 sheets. So this is 12/8 times 10 to the 15 sheets. Can anybody reduce 12/8? 1.5. So this is 1.5 sheets. We have basically, 1.5 times 10 to the 15. So as a quick estimate, it looks like we don't quite make it. It looks like we're going to be about 2/3 of the way there. And if you do a quick search on Google, it actually tells you it's about 2/3 of the distance. Our calculations are fairly accurate. I'm not making too many mistakes here. This gives me a rough estimate. What's amazing is not that he was wrong, but just one more fold would have done it. 51 folds would have been enough. 50 is just not quite enough. But you want to be able to get ballpark estimates for things in life. You want to get a sense of how long is something going to take. Is there any chance of being able to finish this? It is one of the most valuable skills you can get. Does the answer look reasonable? One of my former students was working at a big financial firm years ago, and he did one of these quick tests. And he said, this result doesn't look right for what we should be doing. And he eventually found that there was a coding error. Something was off by a sign, and it saved many millions of dollars for the company that this was found before things were done. You want to have a rough sense of, can you trust what's coming out? It is possible that some of you just don't play well together. And that's why the time actually got worse as we added more people. But just looking at what was going on, the data wasn't what I expected would happen. So I want to get more data today. But I thought this would be a nice, fun exercise. If anybody wants to actually try to do this, I have to fix the printers upstairs because nobody else seems to replenish the printers, and both trays were empty. If anybody wants to try to see how many times they can do it, if anybody thinks they can get to 10, it'd be amazing. And so I will leave this here for people if they want to do that. Any other quick questions on calculations like this? But I know some of you are applying for various jobs and having interviews. Stuff like this is absolutely something that can be asked on an interview question. They often like to ask, are there more Lego tires or real tires in the world? Or how many people do you think in the world have the following? And you need to come up with, on the spot, a reasonable model to get the answer. They often don't care if you're actually right. They care about your thought process. Are you attacking in a good way? Are you thinking of what the right factors will be? For a lot of these things, it comes down to sometimes, what do you actually know? I don't really need to know that much for this, but I do need to know how far the Earth is from the sun. If I don't know that, I'm screwed. So I would need to be able to get at least some rough estimate. So if I know the speed of light and how long it takes light to go, or how far light goes in a second, I can then use that to estimate. Or I could know the distance directly. If I don't know either of those, I've got to come up with somehow some rough estimate for that. The other thing is I need to estimate the thickness of one piece of paper, one sheet. I don't have anything remotely accurate enough to measure this. And this is a really nice idea. Sometimes rather than doing one thing, do a bunch of things and then take the average. So it's really hard to measure just one thing, but if I can measure 500 of them, that's not so bad. Anybody know the Princess and the Pea story? Yeah. So do I actually have 500 sheets of paper in here?
No.
No. Why not?
It's average it out.
Well, so the question is, what is the fluctuation going to be? Do we really think it's going to be 500? Is the process that good? Could it be off by 1 or 2? I would expect for a product like this, it probably is 500. But again, I could count it, or better yet, I could have my students count it. There's an advantage to being a professor. Or I could basically say, I don't care. It's not going to be off by that much. It's not going to be 450 or less. It's not going to be 550 or more. It's going to be close enough that this is a good enough estimate. And if I'm just ballparking the thickness, that should be fine. All right, so I'm going to stop the recording now. If anybody has